So here in this video, I'm just going to be going over the basics of inverse trig functions and what they are and what their domains and ranges are for the most basic of the trig functions. So an inverse trig function, keep in mind, inverse is different from the reciprocal. We're saying we want to, instead of plug in an angle and get some ratio, we want to plug in ratios and get back an angle. So if you had your basic equation, sine theta, let's say sine theta is equal to 1/2. You would solve that equation generally by going to your unit circle, knowing where sine theta is 1/2, choosing from there. You have, though, unless you were restricted in the domain by your problem, you have infinitely many solutions to this because you could always go around the unit circle as many times as you want. For this, in the first rotation, we would have answers of pi over 6 and 5 pi over 6. But technically, we could go as many times as we want. Pi over 6 plus 2 pi n, meaning as many rotations around as we choose, both either side, and 5 pi over 6. Plus 2 pi n. So what an inverse trig function does is it switches your outputs and inputs. So the inverse trig function, you would be called arcsine, or we could just call it sine -1 is another way of writing it. So if we're going to use the same example, so we're saying arcsine of 1/2. So another way you can think about this is saying sine of what angle is equal to 1/2. This is essentially saying the same thing. The arcsine of 1/2 is equal to that angle. However, I want to note that inverse trig functions is an important notational way of saying this because these are indeed functions. And what's the characteristic of a function? You can't plug in one thing and get multiple answers. So the arcsine of 1/2 is not all of those things I just wrote there. You would only be allowed to have one thing, and this is where your range restriction comes in on these functions. So, on the unit circle, we can use our mnemonic, all students take calculus, for knowing which trig functions are positive, all sine, tangent, cosine, for our which trig functions are positive. So it's just mathematical convention to say, all right, we need to describe this function arcsine, but we can only have one answer. So we're only allowed to choose one quadrant where sine is positive and one quadrant where sine is negative, and that way we'll always have one answer and only one answer. So the only ones where sine is positive are these two. The only ones where sine is negative are these two. So in order to have two that are, touching, to make this nicer, we're going to choose these two. So we have this range here, all the way from negative pi over 2 to pi over 2. And you'll notice that same range also works with tangent. So this is a range for arcsine and arctan. So we have a place where these are positive and a place where they're negative. However, if we wanted to do cosine, choosing this wouldn't work because that would only give us positive results when we know we can sometimes have negative results. So for cosine, we use these two, which would be 0 to pi, and that's for arc cosine. So what this means in terms of answering this problem here now is that arcsine of 1/2, like I said, even though sine of theta equals 1/2 gives you all of these answers, arcsine of 1/2 has to give you one answer. So basically what you're asking yourself is, which of all of those responses is in this range right here? Negative pi over 2 to pi over 2. Well, the answer there would only be pi over 6. Which is the same thing, because this is the other way of writing it. So the arc sine of 1/2 is pi over 6. So what you need to be careful of for problems like this is that this equation and this equation are similar, but they're not the exact same. This has infinitely many answers, while this only, by definition, has one answer. So let me just do one more quick example. So if I wanted to find the arctan of -1. So the best way I feel to answer these questions is think to yourself, this is saying the tangent of what angle is -1, but that angle can only be in that range. So this is the same thing as saying tan x equals -1, but only if x is in that range of arctangent. So these two things here, the range for arcsine, arctan, and the range for arccosine, those are things you're just going to have to commit to memory. Those are very important. So where is tan equal to -1? Well, tangent is equal to 1 at angle of pi over 4. It's equal to -1 at 3 pi over 4, 7 pi over 4, etc. is equal to -1 many places. But which of them is in this range? Well, none of these are, so we must be talking about a negative angle here, because we can't go past pi over 2. And if you notice, the first positive one is past pi over 2. So we want an angle in the fourth quadrant. Well, our fourth quadrant angle, 7 pi over 4 is in the fourth quadrant, but it's not in this particular range. So we need another way of writing that same thing. So to get to 7 pi over 4, let me go over here. 7 pi over 4 means you went all the way around to there. Let me write that here. Because you can see 8 pi over 4 would mean you went all the way around 2 pi. Well, what's the other way of getting to that same angle? We could have just started here and went down. But what would you call that? Remember, when you go in a clockwise direction, you count that as negative. So this would be... So these two are the same thing, but we wanted something in this range. We have that here with -pi over 4. So our answer to this would be -pi over 4. So inverse trig functions are ways of solving for an angle in a trig function. However, they only give you one answer, and their ranges are very specific. So those are two things that you have to keep in mind, and oftentimes you're going to have to do what we just did here in finding a coterminal angle that's in the same in the range that you need.